In the following clip, we will care for some more skinning adjustments. Before we continue to do so, we will create a UI layout that makes it most easy for us to edit the effect of our controls. So what is always a nice idea also for the animator when you want to use the controls for the face is that you have two separate cameras, one which is focusing your character and the other one which is focusing the UI. So for that we will open the outliner. And now I will just simply copy my perspective camera to make it the camera focusing the UI. So I press Ctrl D on the keyboard to duplicate it, and this will become my UI cam, so this is why I'm renaming that. And I will drag it up to the section where all the other cameras are too with the middle mouse button. Letting this camera focus the UI is pretty simple. First of all, of course, we have to make it active in the viewport by right-clicking on the camera symbol and then select the UI cam here. And next thing that we have to do is simply selecting the things that we want to focus and pressing F on the keyboard. What we want to focus are the controls, in this case the mouth controls. So we're selecting them, pressing F on the keyboard, adjusting the camera so that we can see that a little bit better, and actually that's it. The only thing that we need now is a second camera to be visible in the viewport, which shows our character. For that we need a viewport layout which allows us to have two cameras visible in the scene. For this you can simply grab, for example, this layout which says two panes side by side. If you do not see that in your UI, you can also right click and then choose two panes side by side here. So now you can see that we have two cameras visible. One is the UI camera and the other one we can simply make to our character camera by right-clicking the camera symbol in here again and choose perspective. And now we can zoom onto our character. Now we can drag out the outliner. Just grab it with the left mouse button and drag it somewhere where you can't see it and close it or whatever you want to do with it. And now you have created a layout which is perfectly suitable to edit the effect of your controls. To finish that, what we can also do to see the character and the effect a little bit better is to make the texture visible by clicking 6 on the viewport of the character. And if you want to see the wireframe on your character to see the smoothness of your deformation better, then you have to click on this symbol up here. What you surely will have realized while working on the driven keys for your channels is that there is still some issues in the skinning. No worries, that's normal. The final skin weight editing is best to be done after you have created the channels, and you will see why I'm doing that it is really quickly done. Best to be seen are those skinning issues when you drag the mouth up and down. First thing that you can see, of course, is the intersection of the lower lip. So here we have to do something. And of course, the crumbling, which occurs in mostly the upper part, but also a little bit in the lower part. Because we are just caring for some tweakings of some crumbling of the shapes, the tool which is best to be used to fix all of this is the weight hammer tool. So let's open the Paint Skin Weight tool again. Go to the selection mode and fix all the crumbled vertices with the weight hammering. You best do it one by one because the algorithm will otherwise work a little bit differently. So choose vertex after vertex, and we will only do it on the left side. All the crumbling on the right side, admittedly, mostly comes from not mirroring the skin weight editing in the last step that we have done before. So we are going to make up for that now. And don't forget to put the character in a neutral pose before you are mirroring the skin weight. Of course, you can also do the mirroring only at the very end when you are completely done with smoothing out the skin weight, with which we will continue now. As you can see, only using the weight hammering does completely the job for smoothing out the skin weighting for moving up the lips when you already have done the rough skin weighting before. When you are pleased with the deformation of one control, then continue to check also the other controls. What we can see especially here is that we should have done a little bit more smoothing from the head towards the joints in this area. Also try to fix this with weight hammering first, And when you see that you cannot do the fixing with the weight hammering, then go on and continue editing the single joint weights by shifting the weights between head joint and the appropriate mouth joint as we have done before. Whenever you see that the weight hammering does not lead to a pleasing result, undo it and try with a neighbored vertex, or go for shifting the weights between joints again. And when you are finally done, then you can go for mirroring the joints, and do not forget to bring the character in the neutral pose before, as always. Now do a final check with your deformation of all the controls, and as you can see, that wasn't too bad, was it? When you are finished modeling all the blend shapes, you are now assigning them to your original geometry as a deformer. You have to select first all your blend shapes, then your original mesh, and then you go to Deform, Blend Shape, and again the options. In the options, it is important that you have set in the Advanced tab the deformation order to pre-deformation when you additionally also work with joints, what we are doing at the moment. If you have set this, then you can click Create, and you can see in the inputs of your original object that a blend shape node is being added. So if you want to have a quick look at the deformation, then we can just open this by clicking on it. And here you can see the list of models that we have added to our blend shape deformer that our object shall be able to morph into. If we change the value of one of those entries, our original object morphs into the shape of the matching object. Of course, it is not advisable to leave your blend shapes with such unidentifiable names. So you could have renamed your blend shapes before, or as we will do it afterwards. To do so, go to Windows, Animation Editors, Shape Editor. This opens the Shape Editor window, where you can see the same entries as in the inputs on the right side. To better see the blend shape editor and my model, I will dock it onto the left side of my window by just dragging it over until I can see the blue line and then releasing the mouse button. By double-clicking onto the name of the single entries, I can change the name. As we can see by the deformation, this is the mid-brow going up. Now we can go through the rest of the entries, checking the deformation on the right side and renaming the attribute accordingly. By watching the deformation caused by these blend shapes, you can see that all of the single channels are already working pretty fine. But now let's proceed to the next step, where we want to combine those channels to create the special emotion, because the combination of channels in the end is what makes a good rig. So let's see what happens when we are moving the whole eyebrow up, as would happen when we want to go into the surprise expression. While brow inner up alone looks pretty good, it already starts a little bit crumbling when we are adding the brow mid up, and it is completely crumbling when we are also adding the brow outer up. This upper line is anything but even, and of course should be avoided in any possible combination the animator can do. Before we are going to see how we can fix this, let's first analyze where this is coming from. Let's take this simplified example. We have the line in the middle, which shall be deformed once to be lifted on the left and once to be lifted on the right side. For this we created those two blend shapes and assigned it to the middle line. When we look at those shapes individually, then this deformation works pretty well. And when you want to lift the line completely, then you should expect that combining both shapes should lead to a complete lifting. But it's not. Let's check what's going on by moving both blend shapes in the same position. This is the trouble-causing area. This is where the deformation of both shapes overlap. When we have a closer look, then we can see that the addition of the deformation at this point doesn't lead to a 100% lifting compared to the both sides. So what we would have to do to achieve a 100% even lifting is to add the deformation in the overlapping area in a way that it adds up to 100% compared to the rest. Of course, the balancing of this overlapping part when you are modeling on your blend shapes individually is pretty hard to judge. It looks as good in this shape as in the unbalanced shape. On the other hand, when we are working with joints, the balancing of the overlapping area, which shares the deformation between the group of joints that we assigned to the object, is done automatically. So lifting them both individually looks as fine as lifting them both together. And when you want to edit the deformation for one joint, then the added or removed influence for this one joint will automatically be shifted to the other joint. Remember the example with the cake. So that whatever you are doing with the deformation, it always leads to an even movement when you are moving both joints together in the end. So let's prove this theory with our facial rig. When we are moving all the joints together, you can see that this leads to a pretty even deformation. In case it does not in your example, then the only reason for this can be that still the head joint owns some influence in this area. And this leads to a not moving of part of the geometry when we are moving the joints. So if you are sharing this area completely between the three joints, then you will always generate an even movement by lifting them all together. Before we start refining the skin weighting, what I absolutely have to emphasize at that point is that the key to a successful and painless skin weighting is locking the right joints. So whenever you feel that Maya is not doing what you want it to do while doing the skin weighting, then please check your lockings first, because it's most likely that the troubles you are having are only resulting out of this issue. So before we are proceeding to the next step, I will first turn off the X-ray joints option so that we can see better our geometry. We will now smooth out the transition areas between all the lip joints. We will start with the mid-up lip joint and will then go clockwise around the lips. For selecting the border edges of the influenced areas, do the same method as we used in the last clip. What we do now is smoothing the weighting here by letting the weights be shared between two joints. And whenever you want to have two joints sharing the weighting of a certain area, then you should go for a proper locking, meaning all the joints shall be locked, besides the two between whose you want to share the weighting. And after that, you can now drag the value slider for one of the joints until you are pleased with the deformation. Repeat those steps for all the border loops of all the areas for the appropriate joints. And while you are doing that, please keep in mind that it is absolutely necessary and crucial for a good-looking result that you are disciplined enough to always check the locking of the right joints before you are going on with the next smoothing out of the next loop. When you are finished with this step, your deformation should now look somewhat like this. So the smoothing between the single lip joints is perfectly well done. The only thing that is missing is the smoothing of the outer area of the mouth, so between all the lip joints and the head joint, and all the lip joints and the jaw joint on the lower side. When we want to do that, first thing, as always, is to lock and unlock the right joints. So we want to smooth the transition between the head, and we will start with the mid joint on the upper lip. For this step, it's best to go through vertex by vertex, so this is why we are switching back to the vertex mode again. Now you reduce line by line, starting from the top, the weighting for the lip joint. In the top row, make it very, very low. In the following row, make it a little bit more. In the following even more, and so on until the vertices defining the lips directly remain fully weighted to the joints. You will have to touch more or less each vertex individually to define a smooth deformation. Do this smoothing as well in the outer mouth as in the inner mouth area. And repeat it for each of the lip joints. As always, do not forget the locking of the right joints. When it comes towards the mouth corner joints, please remember that the lower area shall be shared not between the head joint and the lips joint, but between the jaw joint and the lips joint. So somewhere during the process of defining the smoothing of the lip corner joint, you have to switch from locking the jaw joint to locking the head joint and unlocking vice versa. When it comes to the inner side of the lower lip, it is pretty hard to touch the appropriate vertices. What you can do here is either go to a frame in the timeline where the mouth is open to better be able to select those vertices, or you have to go to the wireframe mode, which means that you have to press 4 on the keyboard to see better which vertices to touch and where you can move them. You might wonder whether it wouldn't have been a better idea to do not define such a huge range for the single joints at the beginning. And the answer is clearly no. Of course, you are very welcome to try that on your own. You will then see that instead of decreasing the weights for the lip joints, you will then have to increase the weights for the lip joints. And that doesn't make less work. In the end, it makes at least the same amount of work, if not even more, because you always have to check out that in the most extreme deformation state, vertices are not starting to overlap each other. However, in the end, it is a very similar process, whether to reduce or increase the weights of the lip joints. So again, you are welcome to try the other way and find out if this fits better for you. When you are done with the smoothing process, your deformation should approximately look like this. Don't worry about the deformation in this area. The only reason for that is that the mouth corner joint is not yet moved while opening the mouth, and that will be fixed the moment when we assign the joint movement to our animation control. And when we create the jaw open animation control, then we will let the mouth corner joint with the driven key also be moved, and this will fix the deformation of this area. As the last step, you can now mirror your skin weights. Again, make sure that you select only the jaw region for the mirroring and that you are in a neutral pose. because if you are in any deformation that is not symmetrical, the mirroring won't work. So now that we are done and pleased with the single channel movements, we have to check the combinability of those as we have done for the eyebrows. The channels that have to work together are, for example, the lip corners, horizontal and vertical movements. So when you drag the control not only to one side but to both sides simultaneously, then the result here should also be a pleasing one. Let's have a closer look at that. What we can see in the mouth corner is that we have created a curvature here, which is not quite ideal for a smile expression. So what we would have to do is to adjust one of the channels, in this case probably the mouth corner up, to create a better curvature. The problem here is that only the mouth corner up is actually doing the job, so it's looking fine. To better edit the channels while seeing the combination of those, what we can now do is going into the driven key curves directly and edit them. For this we have to open the graph editor and dock it on your panel layout. And let's have a closer look at the curves that are driving the mouth corner joint. To editing the curvature, what we would have to do best is going to the rotation channels. So we can scroll down here and let's have a look at the rotation channel for rotate Z. In this list here you can see all the driver curves from all the controls. And what we are searching for now is the outgoing driving curve from the mouth corner control, which is this one, translate Y, because this is controlling the up and down movement. And what we can do in here now is controlling the effect of the rotation of the mouth corner L translate Y by editing the keyframes of the resulting curve directly. I just zoomed out a little bit as you would do in the viewport by pressing Alt and right mouse button. Together with Shift you can control whether only to zoom horizontally and vertically, so we have more space to edit the curve. So for example, we can move that up and down. To do that, you have to be sure that the Move tool is active. Then you select the appropriate key. And now, with pressing Shift on the keyboard and at the same time dragging with the middle mouse button pressed somewhere in the graph editor viewport, you can edit the effect of this channel. And you will directly see the effect on the combination of mouth corner up and mouth corner wide without having to go back to the Z-driven key window. So this makes it already a little bit better, but we cannot change the effect in this area. For that we would have to go to those two joints and edit the keyframes for them as well. So again we would need the rotate Z for the mouth corner L, and we will need that for both joints. So I have to scroll down in the list searching for the next joint, which is here, and then again for rotate Z and also for the mouth corner L, translate Y, because this controls the up and down movement of the mouth corner. When I want to select this additionally, I would have to press Control on the keyboard while I'm selecting this. And now I have both the curves that I need. And again, I'm selecting the keyframe and dragging with the middle mouse button and shift on the keyboard pressed these curves and see what comes out of that. And now we can see that we can fix this rotation by doing it a little bit less than it has been done before. This already looks way better. Question is, how does it look like in the single movement without the mouth corner wide? And you can see that, okay, this still works. Of course, it's not perfect, but we will adjust this with the corrective blend shapes later. What we have to do with the combinations as well with the single channels is to check them from all perspectives. So let's go to the side view and see how the combination looks there. You can see that the mouth corner joint is driven too far in the Z-axis. So we have to check in the graph editor, the Z translation, and also the one which is controlled by the mouth corner L control translate Y. Again, we are grabbing the last keyframe of the mouth corner L control and we are editing the curve until we can see that the shape looks better now. There is still a bulging, which is obviously not coming from the translation Z, so it can only come from the rotation. Let's quickly check which channel this is, and you can see this is the rotation Y channel, the green one. So let's search for this in the graph editor. Now we have to find out whether the horizontal or the vertical movement of the control is driving this rotation. And as you can see, it's the translate X, because we have a bigger difference from the 0 keyframe to the maximum keyframe here. So we're selecting it and then moving the curve until the shape fits. Okay, that looks better. And again, of course, we have to check now for the single channels if they still look okay. Yeah, that's okay. And that's okay too. The next step we are going to do is using a so-called aim constraint to control the rotation of the eyes by the position of those two controls. Before we are doing that, let me quickly explain the techniques behind an aim constraint to you. You can easily control the orientation of an object by a position of another object. When we are moving the circle, you can see that by aiming onto that circle, the other object is rotated. This only works to a certain degree, because what we cannot control with the position of this object is the so-called twist rotation, meaning the rotation around the object's own axis. If we want to control this rotation too, we would need to define a so-called up axis for this object, which then is forced to also aim to another object, which is the so-called up vector control. Of course, which axis of the object should target the aim object and the up vector object is not defined by the object's shape, but technically spoken by its transformation axis, which is the z-axis, the y-axis, and the x-axis. In that case, the z-axis is targeting the aim object and the y-axis is targeting the up vector object. And this is how you have to understand the concept of setting up an aim constraint. With this knowledge, we can now apply the aim constraint to our object properly. For all the constraints, you always have the same rule. You are selecting the controlling object first, which is the animation control in our case, of course, and the controlled object last. Then you go in the rigging menu to constrain and aim, and most important, the options to set them up properly. To understand what you have to set up here, you have to understand the general principles of aim constraints as I have explained before. And for that, of course, it is absolutely important that you know about the object axis of the object that shall be controlled. For this, we have to select it and go to the Move tool. And the move options must be set to object so that we are sure that we can really see the object's own axis. To assure that, you have to press the W button on your keyboard, keep it pressed while also pressing the left mouse button, and make sure that the object checkbox is checked. So now we can be sure that those axes are the ones of the object itself, and we can see that the Z-axis, the blue one, is already aiming towards our control. So this will be the axis that we have to define as being the aim axis. That's this section here. And those three numbers that you can put in there, you can interpret as X, Y, Z. So if we want to have the Z-axis of the object pointing to our aim control, we have to put the other axis to 0 and the Z-axis to 1. What is a little bit more complicated to understand is the up vector setting. The settings how to be seen here are the default settings, and actually in our case perfectly the right ones. Nevertheless, of course, it is important that you understand those settings, because in other cases than the eyes, it might be that you would have to change them. Because it's not needed in the case of the eyes that we control the twist rotation for the eyes, that would really look weird. We only have to make sure that the object is always pointing into the same direction. So for that case, it is properly suitable to set the world up type to scene up, because now the object refers to a general world orientation and is not controlled by any other thing. In the case of our object, the up vector that we want to define is the green vector, which is y. So again, when you see the up vector numbers here as x, y, z, we have to set the second number to 1, which represent y, and the other two to 0. And we want to define that this vector always should point upwards. Technically spoken, upwards means the world y vector, because the world vectors are never changing and the y vector is always pointing up. This is automatically set when you set the world up type to scene up. You can also define a custom vector here if you want to. And then you could change that world up vector to the X or Z vector or whatever you want to do. So another perfectly legal option here would be to align the X vector of our object always to the X vector of our world. Also here, nothing would change during the animation. But because aligning the up vector, which means y, to the up vector of the world is the default, we would just keep it like that. So for the explanation, I changed my selection. I have to redo the controlling object and controlled object selection again. And now I can say apply. And when I'm moving the controlling object now, you can see that this rotates our eye. So the same we will do for the other eye, selecting the controlling object and the controlled object, and again say add, because the settings here are perfectly the same. So now that you have done this, you can select both of your objects and rotate them, and the eyes are following that look at point in space. And the good thing on the other hand is that when you are selecting the joint, which controls the head, and rotate this one, the eyes are still focusing the point which you just created for this setup. There are some more preparations that have to be done to generate a proper control object. To understand that, you have to, for a short moment, switch the perspective towards being the animator. By using animation controls, of course, you sooner or later move them out of the default position. Okay, now we have a reference of where the default position is. But what we have to do when we want to move it back to this, we still have to kind of guess where approximately that default position is. But sometimes you want to hit exactly the default position. And you want to do that for more than just one slider, but maybe you want to reset the whole face. And then, of course, it's pretty uncomfortable if we have to touch each slider individually and do the approximate guessing of where to move the slider for each slider on its own. So what is more comfortable is when we can grab all the sliders at once. Imagine we would have more than this one. And then we just put a number in here that represents the default position. And for the moment, the default position would have a number of 14.177 in translate Y. So it's completely unacceptable for the animator to remember for all the sliders the value for the default position. And this is why we have to assure that the default position for all animation controls always is 0. What we in this case can most easily do to assure this is simply select the object where you want to reset the values for, and then you go to Modify Freeze Transformations. This is not always possible for all animation control, but for those slider controls, this is doable. What you can see now is that all the translation, rotation and scaling values are reset to the default value of 0 for translation and rotation and 1 for scaling. What is exactly what we want to have. Next thing that we have to do when we want to have a clean slider is that we are checking the minimum and maximum value, which also shouldn't be some random values, but the default for minimum and maximum of facial controls is -10 and +10. Let's check what we have now. As you can see, maximum is at 1.048 and the minimum should be something similar in the negative way. There's a simple trick to adjust transformation values to other positions in space where you want them to be. For this, we have to first of all group the control object by simply pressing Ctrl G on the keyboard. Next thing we have to do is to adjust the pivot of the created group to be in the center point of the control object. By default, the pivot of the group is set to the position of the parent object. In that case, it was the world, so the pivot sits in the world position. If we want to center it to the object, then we just go to Modify, Center Pivot. Next thing we do is we are selecting the control object itself. Be aware that at the moment you still have selected the group. What we want to select is the control object, which is inside the group. So either you click it on the outliner or you click it in the viewport again, so that you have selected the right object. And now you set it to the value that you want to have as being the maximum. In that case, it's translate Y, and the value is 10. So you can see that it's way too high at the moment. Next, we are selecting the group again, and we scale the group down until our object hits the right position. Don't worry about the resizing of the cube. That is simply modified later in the cube object itself. So we are selecting the cube again, go to the input, and adjusting the width and height of the cube so that it matches the visual reference of the slider. So when you now move the control object, you can see that the minimum value is approximately -10 and the maximum value is approximately 10. So this is exactly what we want to have. And when we reset that to 0, then it goes back to the middle, which is the default position. The last thing that we have to do to set up the slider properly is to restrain the transformability of the slider. So we have to make sure that the slider is not movable in any other axis than up and down, which means translate Y. And we have to make sure that the translation Y cannot exceed the +10 and -10 values. For the first thing The only thing that we have to do is to select any other attribute but the translate Y. You right-click and say Lock and Hide selected. So now no other axis can be moved, neither translate X nor any rotation channel. To additionally limit the movement of the remaining axis, you have to go to the attribute editor again, pressing Ctrl A. Make sure that you have the transformation node selected, which is the first tab in the row. Then you are going to limit information, translate, and you check translation limit Y, minimum and maximum. And here you put in the numbers -10 and 10. And if you now try to translate it, you can see that the only possible translation is moving the thing in its predefined limits. To finish the slider creation, we should give our control object a proper name, as well as the group. Remember that this is just the template, so we will just put control in here and rename it later after we duplicated it for creating the final control. And at the very end, we have to create one group for everything that we have created now. For that, we are selecting only the topmost objects in hierarchy, which is the 2 groups. Make sure that really only the 2 groups are selected and nothing inside. And then we are grouping it by pressing Ctrl G again. And give this thing a proper name. Something like Group Slider Template. In this clip, we will connect the mechanics to the controls using the techniques of driven keys. The goal of the connection that we want to do should be the following. If we are moving this control up, then the blend shape that triggers the inner brow on the right side should be activated. Whenever you can phrase the connection that you want to do with an if-then sentence, then probably driven keys are the right techniques that you should go for. But let's have a closer look at what happens when we are using driven keys. When using driven keys, you are using an animation curve as being the link between the attributes of the controls and the attributes of the mechanics. In Maya, you are using the graph editor to look at those curves and edit those curves. When you look at the graph editor, not as being an animation tool, but a simple coordinate system, then the driven key mechanics is explained like this. The vertical axis represents the driving attribute of the control. In our case, this is the up and down movement, which in Maya is always translate Y. The horizontal axis represents the object that is controlled, in our case the blend shape. By setting driven keys, you now define the relation between the driving attributes value and the driven attributes value, which means that if the control translate Y is set to 0, then the blend shape should also be set to 0. And if the control translate Y is set to 10, then the blend shape should be fully triggered, which means a value of 1. Everything in between those two extremes is then automatically interpolated by the curve, so that the blend shape automatically moves to the right amount when I'm moving the control. So let's see how you can set up this connection. If you always stick to the if-then phrase of what you want to do, then it's actually rather easy to create this. First of all, we have to consider which attribute is the one that shall be controlled, so the driven one. In our case, it's the blend shape. And the blend shape is to be found as being an input node of our geometry. So we have to click on the blend shape node and choose the right attribute that we want to be driven. In that case, it's the brow inner up on the right side. Next, we go in the menu of the channel box to the Edit entry and in here to Set Driven Key. That opens a window that you can read as this. In the upper section, you can load the driving object, which in our case is the control. So you select the control, and then in the Set Driven Key window, you go to Load Driver. In the lower section, the driven node, which is the blend shape, is already be loaded, so we do not have to do anything in here. Next thing that we urgently have to do and never to forget is to not only load the objects which shall be connected with each other, but also their attributes. Because of course you could either connect the translation Y, which is the up and down movement, to the up and down movement of the brow, or you could also use the horizontal movement, which in our case makes no sense, but how should Maya know? So this is the reason why you also have to select the proper attributes in both cases. That means we want to have the up and down movement of the control connected with the brow inner up attribute of the blend shape. Next thing that we now have to do is this if-then consideration. So we have to think about which attribute values should be the related ones. In this case, we say if the control is set to its original position, which means 0 in translate Y, then the blend shape should not be triggered, which means that the brow inner up R attribute should be set to 0. We can check that when we click on the blend shape node here, and then you can see it is set to 0. And if this relation is set right, then we can click in the Set Driven Key window on Key. Same thing we do for the other extreme. So when the control is in translate Y moved to its upmost extreme, then the blend shape brow inner up R attribute should be set to its extreme, which is 1. And when we have set both attributes to the relating values, then again we can set key. And after we have done this, when we are moving the control, you can see that the blend shape is triggered automatically and moves with the control. Keep in mind that by creating driven key connections, you are creating actually animation curves which can be edited. So let's have a look at them. For this, you should select the driven node, which is the blend shape. Just click on them in the Set Driven Key window. And then you go to Windows Animation Editor's Graph Editor. What we can see here is the flat tangents of the animation curve, which means that whenever we start moving the control upwards, there is at the beginning hardly any movement at all for the brow, followed by an acceleration. When you create the same flattened curve for the brow down movement, then the result would be the following. When moving the control up and down, you can see that there is kind of a stop in the middle when the control crosses the 0 position. This is very unfavorable for the animator. So what you should do for each driven key curve that you have created is making the interpolation between the extremes linear. And you can do that by selecting all of the keys that you have set, and then you click on the linear interpolation tangent, which you can find up here. Everything that follows now is repetition. So you are connecting all the attributes of your blend shape with the appropriate control and the appropriate attribute of the control, the way we did it before with the brow inner up R. Connecting joints to the controls is almost as easy as connecting the blend shapes to the controls. There's just one big difference. When you're connecting the blend shapes, then you already have a predefined shape, which only have to be connected to the maximum or minimum of the controls. In case of the joints, you did not yet decide about how the maximum control should look like as being the deformation in the face. And this is what you have to do while you are connecting the controls to the joints movements. On the one hand, of course, this means more work. On the other hand, this means that you are way more flexible. Let's just do it, and then you can judge for yourself. What you absolutely have to do as a preparation step before setting the driven keys is checking your driven objects whether they are animated or not, and if so, you have to delete the animation. In case of the joints, we did an animation for having a better skinning reference, and you can see this in the timeline because we have those red check marks here. If we want to delete this animation, there are several ways. I will go for the following one, marking all the attributes that are animated in the channel box, right click and say delete selected. And now you can proceed doing the driven keys. So first of all, we will care for the up and down movement of the inner eyebrow. And for this, we have to load the appropriate objects into our driven key window. This will be our control, which means the driving object, so we select it and click Load Driver in the Set Driven Key window. This is the matching driven node, which means that we have to select it, and then we click onto the Load Driven button of the Set Driven Key window so that it is loaded into the lower section. The next thing, which is a little bit more complicated than with blend shape, is that we have to define which attribute we want to drive with our control. So what is clear is that it is the up and down movement that we want to care for first. And next the question is which attributes of the driven node we should select. Of course, you might think, okay, it's an up and down movement of the joint that we of course want to drive, so we are selecting Translate Y. But when working with joints, you will see that most of the time the whole transformation of the joint must be considered to create the wanted shape in the end. Before you did not yet create the final deformation for this control. You cannot yet know which channels in the end you will have to move. So it's most easy to select all of them, just to be sure and have the freedom to use them all when defining the resulting shape. After that, make sure that the if-then condition is set to the matching values. So that means that if the control is in the neutral position, the joint should also be in the neutral position, what it is. Then you click on Key. And now we will care for the maximum position. So selecting the control, moving it up, because this is what we have selected in a driven key window. And now we will move the joint to form the desired shape. To better see what we are doing, it's advisable to zoom in a little and also turn on the wireframe on shaded mode so that you can better judge whether to produce a really smooth deformation in the end. So let's start with moving it up and then judging the deformation from all perspectives. You can see that this only moving upwards of the joint results in quite a bulge on the forehead that we do not want to have. So we have to adjust the transformation of the joint till finally we have a shape with least volume deformation. And after you are pleased with the resulting shape, you can click Key to define the maximum. Let's see if this works. Select the control, move it up and down, and see that everything's fine. A comfortable thing with driven keys is that you can not only let several channels at once being driven, but also several objects. For example, for the squint, we do not want to only let the inner joint being driven, but also the other two. So what we have to do is select all of those objects that we want to be driven at once and say Load Driven. Select all of them in the Set Driven Key window and at the same time all of the attributes. And do not forget to change the driver channel as well. So for the moment we want to have the horizontal channel drive the squint, which means all the joints moving to the inner forehead. Because the neutral pose is set as well for the control as for the joint, we can first of all set a key for the neutral position. And now we are caring for the next if-else statement. So if this control is on the very left side of the area, then we want all the joints to look somewhat like this. And you can move all of them as much as you want to in all of the transformation channels. When you are pleased with the resulting shape, then you again set a key and see what happens if you are moving the control. This setting of driven keys you have to repeat for all possible maximum and minimum controller values. Repeat it also for the two sliders for the mid and outer brow. And after you have done so, don't forget to make the resulting driven key curves linear by selecting all of the driven objects, going to the graph editor, selecting all of the curves you can see in here, and set them to be linear. Here comes a summary of what you have to do when you want to set driven keys. First of all, you have to consider what objects are the driving and what objects are the driven objects. To open the driven key window, you first have to select the driven objects, mark the driven attribute, and then you can open the window. Next, you have to load the driving object into the upper part of the window. Then you have to consider the if-else statement. So if one object is set this way, then the other object is set the other way. Then set both objects, the driving and the driven ones, according to this consideration. Then you have to mark the driving and the driven attributes. Do that each time when you want to set a new driven key. And then you can set the key. Now that we have created our templates, we can start with creating the specific controls. For this, I will first move the templates a little bit more upwards, and then I will start with duplication. Let's start with the left eye. For the outer eyebrow, we need an up and down slider. So I grab the slider template, duplicate it, and put it below the template. Then I give it a proper name. The next one I again create by duplication and renaming afterwards. The next control shall control as well the inner brow up and down as the squint channel, so I will use the plane control for this. So you select it, duplicate it, and move it next to the other sliders. Next, what I will have to do is to adjust the initial position for this control. Because we do not want to be able to move the eyebrow outwards, but just inwards, we should place the initial position of the control to the right boundary. For this, we have created this group. So we select it and move it here. Still, the control itself is able to move outwards the boundary, so this is something that we want to avoid. And for this, we go to the attribute editor and change the maximum translation limit to 0, so that we can only go to the left side and not the right side anymore. As you can see, the left side is now in the middle of the control, so we also have to adjust the visual boundaries of this plane control. For this, we need to grab this group and go for a simple scaling, so that in the end, our controller is movable within this boundary. And when we reset it to 0, then it goes back to its default position. And don't forget to rename your control. More important than to rename the groups of the controls, it is to rename the controls themselves. because they are still just named control, which comes from the template. Name them inner brow L, mid brow L, and outer brow L. After having created the controls for the left side, creating the controls for the right side is easy. We just have to grab all of them, move them a little bit to the side so that we have enough space for the right side, duplicate all of them, and move them next to the left side. Rearrange them in a way that they are mirrored and not just moved. And again adjust the initial position of the plane control and the controller's limit. In this case, the minimum translation must be set to 0 and the maximum must remain by 10. And don't forget to rename your controls. In this case, replace the underscore L with an underscore R for the right side. Of course, you can at any time adjust the size of your controls by simply scaling them. It is advisable to not scale all those objects individually, because by default Maya uses the pivot of each object to operate the scaling. Better it is to create another group for any logical collection of objects. This, for example, is now the group for the controls on the left side. And those are the controls for the brow on the right side. And now if you scale those two groups, after you have centered the pivot, you see that the result makes much more sense. And then, of course, you can also adjust the position. This leaves some space for later controls for mouth and cheek area. For a better recognizability of the controls, it is of course advisable to not only group them for a better placement, but to also create a visual group, maybe also a text, so the animator can immediately see the influence region of the controls. So for creating the outline, we can, of course, again go to Create NURBS Primitive Square and place it manually. A little bit more comfortable, I feel it is to just duplicate an already prepared square. What we can do by searching for them in the outliner, by pressing the plus sign on one of the groups and then opening the other groups as long as you can see one of the already created NURBS squares. Now we are duplicating it and afterwards unparenting it so that it is not a child of the control itself anymore, by pressing Ctrl D and then Shift P. Now you can transform the outline so that it wraps around the specific controls and leave some space for a text that explains the area that the controls are deforming. And then of course you should give it a proper name and make it a child of the specific group that you already created by just dragging it with the middle mouse button over the group that you want to make it a child of. A next step that I will do is create the text. And this is done by going to Create, Type. You can see that Maya is automatically creating any typing for you here, which is probably not the text that you want to create. We will care for the size later. Let's first change the text by going in the attribute editor to the tab which is called Type. Here you can insert the name that you want to give this group of controls. In the Geometry tab here, you can define whether you want the text to be 3D or 2D. If you check off the Enable Extrusion, you can see that it is just a plane. And now you simply transform it by scaling and moving to fit to your group. If you want to change the font, do that in the Text tab. To change the color of the text, you will have to go to the attributes of the shader. And the shader information is always to be found in the last of the tabs in the attribute editor. Click on that and then change the color in the color entry. The shader type you can set in here, and I will change it to be a Lambert to not have the reflections. If you want to differentiate the outline color of the outline of the group and the controls, then the most easy way to do that is to select the group for the outline again, go to the attribute editor if it's not already open, and then again to the drawing overrides, which we had before, and instead of setting the display type to reference now, you set it to template. Then it automatically gets a gray color. Repeat all those steps to create the visual group on the left side. In the next step, you will have to build the controls for the mouth, same as we have done in a previous module for the eyebrows. You just duplicate the templates. You have to then rename them, replace them, and that's it. What I have done here is a suggestion of how you can order your controls for the mouth. Maybe you can make your own thoughts and decide for your own design. In case you want to go with mine, let me just introduce what we're going to do with them. Those controls on the left and right side of the upper part of the mouth controls are the mouth corner controls. They are there for moving the mouth corners up and down and making the whole mouth wide and narrow. The middle control here is for moving the whole mouth up and down. And the smaller controls are for the upper lip, up and down on the left and the right side, and for the lower lip up and down on the left and the right side. This thing down here is for controlling the jaw. So we can of course open and close it. And we can also move it left and right to get a little bit more control of an asymmetry. When you have created those controls, you will in the next step have to connect them by driven keys to the mechanics of your face. I will do that quickly because there's nothing new. It works exactly the way as we did with the eyebrows. Before we go on with setting up the driven keys, I want to emphasize one very, very important thing. Actually, the driven key rig is pretty much straightforward and not so difficult to set up. But it can easily get confusing if certain things are going wrong during that process. One thing is that you always have to make perfectly sure before you are setting a key in the driven key window that the right driver and driven attributes are marked. It gets even worse. Sometimes Maya changes your markings in the set driven key windows of the attributes on its own. So it is even more important that you always check the selection if that is still right, even if you set it the right way before. The other thing that happens easily is forgetting about setting some keys. For example, the key in the neutral pose, which is really easily forgotten. If you don't do that one, then also the driven keys are not behaving later on as you expect them to do. Also here, please be very careful and always remember to first set the neutral key before you go into the extremes. The thing that you have to remember is that when you want to select joints, don't do it with the selection marquee because this does not select all the lips joints, but the ones which are children of the jaw are not selected that way. So what you have to do is to either select them individually or just drag a box around the front joints, so to be sure that you have selected all of them and then additionally select a jaw joint. What you can see in the timeline below is that there is still animation on them, which we created for doing the skin weighting. So this we have to urgently delete. Again, I will select those attributes for that, right click and say delete selected. And now we can go on with the driven keys. While the attributes are still marked, go to the edit menu in the channel box and click set driven key. We will start with creating the channels for the lip corner on the left side. So select the appropriate control and say load driver in the set driven key window. Then we have to not forget to key the neutral pose. That is probably one of the most important things that you have to do. So first of all, you are setting a key on each channel, the horizontal and the vertical one, for the neutral pose. By first selecting Translate Y in the driver section, making sure that all the driven channels are selected, and then pressing key. Do the same for Translate X. Now we can start to define the channels. We will start with the mouth corner going up on the left side. So for this, we first have to place the controller to the extreme position in Translate Y. Make sure that you select Translate Y in the driver section of the driven key window as well. And turn wireframe on shaded on so that you can better see the smoothness of the resulting expression when you move the joints. So let's create the pose for the lip corner up channel. What you have to watch out for here is, for example, the rotation of joints. You can use them, but be a little bit careful with this. What you can see best when you do the rotation on the mid joints is the following. The vertices that are driven by the mid joints are by rotation moved to left and right on the upper and lower side of the joints. That doesn't look natural, as the center point of the movement, the lip corner, is driving all the geometry upwards. The other thing that you should watch out for is checking your pose on each perspective. Because the alignment of the mouth from a side view is rather diagonal, you always have to move the joints forward when you move them upwards and backwards when you move them downwards. It can help to keep the original volume of the head by also rotating the joints and not only moving them. If you are pleased with the resulting shape, then you simply set a key in the set-driven key window. To check whether this is working, you simply have to select the control that drives the channel in a set-driven key window by clicking on it. And to move the control without seeing it, you can simply select the channel that you want to move in the channel box, and then with the middle mouse button pressed, drag in the right direction in the viewport. This way you can also set the control to the other extreme, -10 in that case, to do the pose for the lip corner moving down. Again, watch out for checking the pose in all perspectives from the side and the front, and when you are pleased with the pose, then set a key in the set-driven key window. Afterwards, check the control whether it works when you move it up and down as we have done before. Now you can reset it to the default pose by simply putting a 0 into each of the channels. Even if we now set up the main functionalities for our face, there's one crucial thing missing, which is giving the character kind of an unnatural feeling when you are rotating the eyes. What you can check is looking into the mirror, focusing your own eyes and moving the head while doing so. What you will see is that, other than with our character, your eyelids will be affected by this movement and will be forced to kind of follow the movement of your eyes. That is not the case with our character right now, and this is something that we have to set up. The general techniques behind this setup is actually rather simple. We only have to create a dependency between the rotation of our eyes and the movement of our eyelids, for which we already created blend shapes. What we want to create here is a setup that in the end assures that if our eyes are rotated upwards, our uplids are opening and our lowlids are closing a little bit. And if our eyes are rotated downwards, our uplids are closing a little bit and our downlids are opening a little bit. So as you can already guess, this is a setup which is pretty suitable to be made by driven keys. So because the driven attributes are our blend shape attributes, we have to go to our blend shape node, select one of those driven attributes and go to edit set driven key. The driving nodes are our eyes, because with their movement we want to control the eyelid shapes. So we select both of them and say load driver. Okay, I accidentally grabbed the head instead of the eye, so let's do that again. I load driver. Here we go. To not forget about that, let's key the neutral pose first. And for that, of course, we have to decide for our driver attribute. Let's quickly check which rotation is responsible for the up and down rotation of the eye. And what we can see pretty well here is that it is the rotate X attribute which is changing. So let's grab that. And for the right eye, rotate X, we want to control the right lid attributes. So we set a key in the neutral pose, and on the left side we want to control the left attributes. So now let's go to the extreme poses. Rotate the eye downwards as much as you feel that this could be the most downward extreme for the left eye. Let's put a straight number in here so that we have it easier to create the same movement on the right side later on. And now let's go to the blend shape and set the eyelids accordingly. For the uplid, that's rather easy, so we can just control that as much as we want to. So for example, a value of 0.2, or let's make it a little bit less by putting in a number of 0.15. For the lower lid, it's not so easy because interactively you cannot drag that attribute into the negative value range because you only defined the upwards movement for the lower lid with the blend shape and not the downwards movement. Of course, if you want to make that perfectly clean and properly, you should actually create a downward movement with blend shapes too, as being a separate blend shape. In our case, what we can do, because Mayam offers that to us, is letting this attribute be dragged into a negative direction. For this, we have to put in a value manually. So let's go for the same value as we have in the upper lid, but just a negative way, minus 0.15, and let's see what this does. Okay, that's maybe a little bit too much, so let's choose half of that, minus 0.75. That looks better. Okay, if you feel that this is the right value for it, let's set a key, and before, of course, make sure that you selected the right attributes and nodes. Okay, let's see what this does when we are dragging now our control. Yeah, the downward movement, as you can see, already works pretty fine. So this really gives a natural feeling to the whole movement when you are dragging your eyes around. Okay, let's do the same for the upwards movement. Drive the eye either on its own or with the control, that doesn't matter, as much upwards as you feel this could be the most extreme. And then again, let's go to our blend shapes again. And let's drag the low lid as much as you feel is right. In that case, I would say 0.2 should do. And for the up lid, we again have to go to a negative way. And I will go for minus 0.1 just to check if that works. Yeah, there is a little bit of an intersection, but that's not too bad. So I would say this is fine. And then again, we are setting a key. So let's see how this is working with our control. And you can see that works quite well. So same thing we have now to do on the other side, which is pretty easy. Just select the right attributes on as well, the driver as the driven side. Then rotate the right eye downwards as much as we have done for the left eye. So I remembered the value, which was 20. And then we go to the blend shape and do this for the attributes here as well, same way as we have done for the other side. So the uplid was driven to 0.15 and the low lid minus 0.075. And then we can set a key. Careful here, sometimes Maya automatically changes the selection of attributes, and that can lead to some confusion, of course, if you now key the blend shapes on the left side instead of those on the right side, which we are working on at the moment. So let's select them again and set a key. And same we have to do now for the other extreme. So in that case, I didn't remember, so I have to check that again by driving this attribute as long as I can see the lids are not moving anymore. So somewhere around here, I would say. And let's do the same with the other control. And then we're going in and setting the same values for the right side as we have done for the left side. And we can already see them in the upper part, so it's pretty easy to recreate that. So minus 0.1 and 0.2. And again, set a key. So now when you are dragging your eyes, you can see that this creates a smooth feeling for the eyelids. And same, of course, when you are dragging around the head joint. To edit the deformation that comes from joints, you have to use the so-called Paint Skin Weights tool. To open this, you first have to select the geometry that you want to edit the deformation for. Then you go to Skin and here the Paint Skin Weights tool, and this is opened by choosing the options. We are choosing the geometry centered method, which means that we have to switch to the selection mode. And additionally, we have to switch to the component mode to be better able to select our components. And this is exactly the first thing that we are gonna do. What we want to achieve in the first step is to assign all the pieces, means all the components of the whole geometry, to just be owned by the head joint, which is the lower one, so that no deformation for the moment takes place and we have the complete control over the deformation for the other three joints later on. We have to set the influence value for the head joint, which is already selected, for all the selected components to 1. Even if the value seems to be already set to be 1, this does not necessarily has to be true for all the selected components. So you have to activate the slider by dragging it and then dragging it back to the very end. Now that you have done so, you can see that the other three joints do not own any piece of the geometry anymore by dragging through your animation. Now we are free to add exactly this piece of geometry to our joints that we want them to own. To select it, a nice tool to use is the Paint Selection tool. In the options, you have to make sure that Add to Current Selection is turned off. And then you can paint over the area that you want to select. And thus you have selected all the vertices you need without having to care for not select the vertices on the other side. As a hint, you can change the radius for your selection brush by pressing B on the keyboard and dragging with the left mouse slider left and right. This helps you a lot by selecting the right vertices. After having selected the right piece of geometry for the joint you want to edit, you switch back to the Paint Skin Weights tool by choosing the tool which is still in the tools list and double-click it. After this, you select the right joint, which is the inner brow for the moment, and then you are assigning fully weight for that, so that the area which is selected is now fully owned by this joint, and you can see that by dragging through the time slider. Do the same you did for the first joint for the other joints as well. When you then play the animation, it should look like this. Of course, not yet the result that we want to have. Let's start smoothing the skin weighting by first go over the transition areas between the joints. For this, we are choosing a frame in our timeline which displays the deformation of this area. Now select the vertices of the transition area and go back to your skin weighting tool. To stick to the rules of a flawless skin weighting workflow, we have to lock all the joints but the ones where we want to shift influence for. After this, we can safely edit the weights for the remaining two joints. So we are selecting the inner eyebrow for now, and then we are editing the weights by dragging the value slider so that it becomes a smooth deformation. Same thing we are doing for the next row of vertices. Again, we are choosing one of the unlocked joints and editing the weighting by dragging the value slider. Now we are doing the same for the transition area between mid-brow and outer brow joint. Don't forget to lock and unlock the right joints. And now shift the weights between the two unlocked joints. In the next step, you have to smooth out the transition areas between all the joints and the head joint, so the non-moving part. For this, you always have to make sure that the only unlocked joints are the head joint and the joint which is responsible for the area that you are working on at the moment. And now you can shift weights between the moving area and the non-moving area, thus making the deformation in the end pretty smooth. Proceed with the next joint and do not forget to lock and unlock the right joints. Remember that you can see best what you are doing when you are switching to the right frame in the timeline, where you can see the deformation of the area that you are working on at the moment. Take your time to work on each vertex individually if necessary. Sooner or later the time will come when you now have to work on vertices that are influenced by three joints, in that case the head joint, the inner brow joint and the mid-brow joint. Now you have to think carefully which joints to lock and unlock. Don't be tempted to unlock three joints, this can easily go wrong. Always think about what are the main joints influencing this special vertex and shift the weight in between those first. As you can see, this reconsideration of what joints to lock and unlock is a repetitive process throughout the whole skinning, but is crucial for having a good result in the end. After finishing working on one area, you have to switch back on the other area again to see the resulting changes and adjust it accordingly. And then proceed to the next joint and smooth out the area in between this joint and the non-moving area, meaning the head joint, first. And again, check the resulting changes on the other joints too and do some last tweakings for the final result, and never ever forget to unlock and lock the right joints. The result should then in the end look similar to this. If you are done with your first skin editing, see if you can create a pleasing result for all the channels that you intend to do by only transforming the joints. For this check, it is advisable to see the wireframe on your geometry so that you can better check the smoothness of the deformation. So, inner brow up and down looks good. Mid-brow could have some polishing. So you can go at any time back to the skin editing process and adjust the deformation. So mid-brow up and down now also looks good. And outer brow up and down also fine. If you are pleased with the channels that you can create by transforming the joints, go one step further and check if you can also achieve whatever you want to achieve with the combination of the channels to reach a certain expression, as sadness, for example. Keep in mind that you can at any time switch back to the default position when you just trigger the first frame in your timeline where still the animation is on and forces the joints to switch back to the original pose. Also here, when you see something that you are not pleased with, just switch over to editing the skin weights again. Congratulations! Now you are done with the mechanics rig of your character's left eyebrow.